In this video, I want to introduce you to solving linear equations of one variable. Equations are a basic mathematical tool for solving real-world problems. And in most equations we study in algebra, it contains variables. And most of the time, those variables or unknowns are represented by some kind of letter, usually X or Y. The values of the unknown that make the equation true are called solutions to the equations. Now, if I have a linear equation of one variable, it's going to look like this. I'm going to have some number A times my variable plus some number is equal to 0. If it's a linear equation of one variable, it can be written in this form. And A and B are any real numbers. So the first exercise or examples that we're going to go through is to determine, let me leave this actually up so you can see it while we're working on this, is to determine whether these equations are linear or nonlinear. So if I look at this example right here, 4x minus 5 is equal to 3 is definitely linear because if I subtract 3 from both sides, I will get 4x minus 8 is equal to 0, which is in the form ax plus b is equal to 0. A would be 4 and b would be negative 8. This example here is not linear because I have an x squared in here. So it's impossible to write it in the form of ax plus b is equal to 0. So this is not linear. This equation, 2x plus 3x is equal to 1, is definitely linear because I can combine the 2x and the 3x and make it a 5x. And then I could subtract 1 from both sides and make it 5x minus 1 is equal to 0. And then I have it in the form of a linear equation of one variable. My a would be 5 and my b would be negative 1. This is definitely not linear because I have x in the denominator and it's impossible to write it as ax plus b is equal to 0. This is definitely not linear because I have the square root of x in there. It's impossible to write it as ax plus b is equal to 0. This equation here is linear because I can rewrite x over 6 as 1/6 x. And then I can add 5 to both sides. And I get 1/6 x plus 6 is equal to 0. So 1/6 would be my a and 6 would be my b. Now there are types of linear equations. You could have conditional, you could have identity, or you could have contradiction. A conditional equation is an equation in which there are some values of x that work for the equation. That give you a true statement, and there are some that don't. So it's conditional, the statement is true or false, and it's conditional based on what you're plugging in for x. So if you have some solution and I plug it in, it's going to give me a true statement. If I plug in something that's not a solution, it will not work. So this is an example of where I would have one solution. So this would be conditional. An identity is when no matter what I plug in for x, it will work because this side is always equal to this side. So if I distribute that 2, I get 2x minus 6. So each side is exactly the same. So no matter what I plug in for x, I'm going to get a true statement. So if I plug in 1, for example, I'm going to get 2 times 1 minus 6 on one side, 2 times 1 minus 6 on the other side. No matter what I plug in, it's going to work. This is all real solutions. It's going to work no matter what I plug in. Contradiction means no solution. It doesn't matter what I plug in, it's not going to work. If I distribute that 1/2, I get 1/2 x minus 1/2 is equal to 1/2 x plus 2. No matter what I plug in, it's impossible to make those two sides the same because this will always be the same no matter what I plug in. But then if I subtract a half or add 2, that's going to cause the difference. And they're never going to be the same. So this would mean that I have no solution. When we solve a linear equation, there's some steps we need to go through to make sure that we solve it properly. And we have to do it in this order for it to work. The first step is you want to clear any grouping symbols by using the distributive property. If you have any parentheses, you're going to distribute what's on the outside of the parentheses so that you can drop the parentheses. If you have more than one grouping symbol, for example, you have brackets and then inside the brackets you also have a set of parentheses, you always want to work on the inside first and then work your way out. The next step is to clear any fractions. If you have any, sometimes you don't have fractions, but if you do have fractions, you want to clear any fractions by multiplying the entire equation by the least common denominator. Step 3 is you want to combine like terms on each side of the equal sign. The next step is to get anything that has an x in it, or whatever your variable is, get all your variables on one side and everything else on the other. Once you get all your variables on one side and everything else on the other, then you want to divide both sides by the coefficient of the variable. That way you isolate the variable, which is what you're trying to do. You're trying to get x equals or y equals all by itself and then everything else on the other side. And then the last step, of course, is to check your answer. And you can do that by plugging your answer back into the original equation to make sure that it works. Okay, so let's use this as our first example. We have 7x minus 4 is equal to 3x plus 8. In step 1, it tells us to clear the grouping symbols. In this example, we do not have any grouping symbols. We don't have any parentheses or brackets or anything like that that we need to worry about removing. So we can skip step 1. Step 2 is to clear any fractions by multiplying everything by the least common denominator. In this example, we do not have any fractions, so we can skip step 2. Step 3 is to combine like terms on each side of the equal sign. We can also skip that step because that's already done for us. On this side, everything that I can combine is combined. And then the same thing on this side. I don't have any x's that I can add to the 3x or any other numbers that I can add to the 8x on that side or on the left side as well. Okay, the next step, step number 4, is to get the variables on one side and everything else on the other. So, as you notice, I have a 7x on one side and a 3x on the other side. I need to get all my x's on the same side. So, what I'm going to do, I can do whatever I want as long as I do it to both sides of the equation. I'm going to subtract 3x from both sides. By doing that, this adds up to be 0. And over here, I would have a 4x. And by doing that, now I don't have any x's on the right-hand side. So everywhere I see x, it's only on the left-hand side. Now I'm going to do the same exact thing with my constants. I want my constants to be on the right-hand side. So in order to add this to be 0, to get rid of it, I'm going to add 4 to both sides. So I have 4x minus 4 plus 4 is equal to 8 plus 4. So I added plus 4 to both sides. Now this gives me 0, and I'm left with just 4x, and this gives me 12. The next step, number 5, is to divide both sides by the coefficient of the variable. My coefficient of the variable is 4, so I'm going to divide both sides by 4. 4 divided by 4 is 1, so I just get 1x. You don't have to write the 1 in there, but you can. And then I have 12 divided by 4, which is 3. And then we want to plug back in and check our answer. So if I have 7 times 3 minus 4, I want to make sure that that's equal to 3 times 3 plus 8. This gives me 21 minus 4, and this gives me 9 plus 8. 21 minus 4 is 17, and 9 plus 8 is 17, so that works. Here's an example of when we do have parentheses. So in the first step, we have to clear the parentheses by distributing. So I have 3 times 2x, that gives me 6x. And I have 3 times a negative 1, that gives me a minus 3. I'm going to carry everything else down. I'm going to do one step at a time. Okay, I'm going to combine my like terms on each side of the equal sign. So I have a 6x and an x, that gives me 7x minus 3 is equal to 5x plus 3. In this example, we don't have any fractions to worry about clearing the fractions, so I can skip that step. My next step is to make sure I get all my variables on one side and all my constants on the other. So I want my x's to disappear on this side, so I'm going to subtract 5x from both sides. That's going to give me a 2x minus 3 on this side. And on this side, my 5x and minus 5x gives me a 0, and I'm left with 3. Now I want to get all my constants on the right-hand side. So I need to get rid of this negative 3. And in order to do that, I have to add 3 to make it 0 and disappear. So I'm going to add 3 to both sides. So I'm left with 2x is equal to 6. My last step is to divide both sides by the coefficient of x. So I'm going to take and divide both sides by 2. So 2 over 2 gives me 1, so I'm left with 1x is equal to 6 divided by 2, which is 3. And then you always want to go back in and check your answer. So if I take 3 times 2 and put in 3 for x, minus 1 plus 3 is equal to 5 times 3 plus 3. Everywhere you see x, you have to replace it with 3. 3 times 2 is 6. 6 minus 1 is 5. So I have 15 plus 3, that's 18. And on this side, I have 15 plus 3, that's 18. So it works. Okay, and example 3, we do have parentheses here. So the first thing we need to do is clear the parentheses by distributing. I'm going to distribute my negative 3. I'm going to take negative 3 times the 5, which gives me a negative 15. And negative 3 times a negative 2x gives me a positive 6x. I also have to distribute my 2 over here. So I have 2 times 2x, which is 4x, and 2 times a negative 5, which is a negative 10. Now I don't have any fractions to worry about clearing the fractions. I'm just going to combine my like terms on each side of the equal sign. I have an x and a 6x I can add to give me a 7x, and I have a -1 and a -15 that I can use to get a -16. On the other side, I already have all my like terms combined. All right, now my next step is to get all my x's grouped together on one side and all my constants on the other. So I'm going to subtract 4x from both sides. That way I can end up with 0 on this side, 0x. Over here I'm left with 3x minus 16. This disappears and turns to 0, and then I get a -10 here. I want to add 16 to both sides. So that way I get rid of this. And on this side, I'm left with a +6. So I have 3x is equal to 6. Now I divide both sides by 3 because I want to get 3 over 3. I want to turn that into a 1 and just get 1x is equal to 2. And then, of course, I'll let you guys check that. You want to make sure you plug it back in and check your answer. Here's an example where we do have fractions. We don't have any parentheses to worry about clearing those. So in step number 2, I want to find my least common denominator. What does 6, 3, and 4 all divide into evenly? That would be 12. I'm going to take 12 over 1 times my 2/3. And then I'm going to take 12 over 1 and multiply by 3/4 x. When I take 12 over 1 times x over 6, I can get rid of the 6 and I can make this a 2, right? 12 over 6 is 2. So I'm left with 2x. Okay, when I take 12 times 2, that gives me a 24. And a 24 over 3 is 8. Over here, if I take a 12 times a 3, that's a 36. And when I divide that by 4, I get 9. So I'm left with 9x. Now this is a lot easier to solve without the fractions. So my next step after clearing the fractions is I want to get all of my x's on one side and everything else on the other. So I am going to subtract 9x from both sides. That is going to give me a -7x over here plus 8 is equal to 0. Now I want to subtract 8 from both sides. So I get rid of my constants over here. This gives me a 0, and all I'm left with is -7x. And then I have a 0 and a -8 that gives me a -8. Then my last step is to divide both sides by my coefficient of x. So that way I get a 1x. So I'm left with x is equal to 8/7. Because the negative divided by negative is a positive. And then you want to make sure you always check your answer. Here's another example with fractions. I have a 4 and a 3 in the denominator, so I want to multiply everything by 12 because 4 and 3 divide into 12. So I'm going to take 12 over 1 and multiply it by 2x minus 4 over 4. And then I'm going to take 12 over 1 and multiply that by 4x plus 3 over 3. When I take 12 times 2x, that's going to give me a 24x. And then when I divide by 4, that's going to give me a 6x. When I take 12 times negative 4, that's going to give me a negative 48. And then when I divide by 4, that's going to give me a negative 12. On this side, if I take 12 times 4, that gives me a 48x. And then when I divide that by 3, that's going to give me a 16x. And then when I take 12 times 3, that's going to give me a 36. And when I divide by 3, that's going to give me a plus 12. Okay, so I just cleared my fractions. Now the next step is to make sure that I get all my x's together on one side. So I am going to subtract 16x from both sides. That's going to give me a negative 10x on the left, and a minus 12 is equal to, and then on the right-hand side, my 16x and my minus 16x adds to be 0, so that disappears, and I'm left with just 12 on this side. Then I want to get rid of my constants on the left, so I have x by itself, so I'm going to add 12 to both sides. So I'm going to be left with negative 10x. This disappears and I get 0, and that's equal to 24. So I'm going to divide, my last step, divide both sides by negative 10. So that way I get 1x is equal to, and then I get negative 24 over 10. That doesn't simplify to be an integer, but that's okay. We're just going to simplify the fraction. I can take and divide the top and the bottom by 2, and that will simplify to 12 over 5. And then, of course, you want to go back and check your answer. Okay, last example with fractions. I have a 5, a 6, and a 3. 30 is the least common denominator here. 5, 6, and 3 all go into 30. So I'm going to multiply each of my terms by 30. So I'm going to have 30 over 1 times 2x plus 1 over 5 plus 30 over 1 times x minus 4 over 6 is equal to 30 over 1 times 2/3. When I multiply 30 by 2x, I'm going to take 30 over 1 times 2x, and that's going to give me 60x. And when I divide that by 5, that's going to give me a 12x. Then I'm going to take 30 times 1, that gives me 30. And when I divide that by 5, that gives me a 6. Next step is to take the 30 times the x minus 4. So I'm going to take 30 times x and then divide by 6. That's going to give me a 5x. Then I'm going to take 30 times a negative 4. That's going to give me a negative 120. And when I divide that by 6, that is going to give me a minus 20. Then I'm going to take 30 times 2, which gives me 60. And when I divide that by 3, I get 20 again. Okay, now I just cleared the fractions. So now on this side, I can combine like terms. I can combine the 12x and the 5x. That gives me a 17x. I can combine the 6 and the negative 20. That gives me a minus 14. And I'm still left with 20 on the other side. Okay, now I have all my x's on one side. I don't see any x's on the right-hand side. So I want to now add 14 to both sides so I can get all my constants on the right-hand side. So I'm going to have 17x is equal to, this is going to add up to be 0 and it disappears. And then I have 14 and 20. That gives me a 34. When I divide both sides by 17 to get 1x, that gives me an x is equal to 2. And then, of course, you want to make sure that you go back in and check your answer.